Hello, my name is Rob Garner. I'm a computer programming instructor, and today I'm going to demonstrate how to use functions in C++. So we'll open up Visual Studio, create a new project. It'll be an empty project, and we'll call it Demo String Functions. I'm going to save it on the desktop. And we're going to add a new item. It'll be a CPP file, which we will call string functions. Next, we'll include our standard items for a C++ program. IOStream for input and output. Use the standard namespace. And then we have our main function. So we've actually already written a function. The main function is in fact a function. But what we want to do is demonstrate writing our own functions. And so to write a function, the first thing we need to do is declare a function prototype. Then we need to do that above where the function will be called, and then below it we're going to write a function that prints a header. And for functions we need to declare the return type. In this case it's going to be void because it's not going to return anything, but void is a return type. Then we have the identifier for the function, and then a parameter list, and we're going to start off with something very simple without any parameters in it. So we just put an open and close parentheses. And we're just going to use this function to see out a header. So that will display a simple header, and this will actually run right now. And this should actually be void print header. So you can see that the function prototype looks very similar to the actual top part of our function. And the reason we do that is because when we call it from our program, what we're doing here is in the program execution is going to start in the main function, and it's going to run down here and it's going to print header. It's going to call our print header function. rather than having all the code inside of main, we can use functions to split the code out into smaller sections. So here we are actually, the execution will go down to print header, display our cout statements, come back, and then return 0. So let's try this. I'll hit Control F5, let it compile. We need to set our link properties. And link in the console subsystem so that we can see our output. And now we'll display it. So we can see that what happened is execution started main, went to print header, did print header, and came back. We can display this, watch this, by using the debug. So I'm going to start debugging. And what we see is we're currently at this point in execution. Nothing's displayed yet because we're up at this point, and if I hit, so next I'm going to step over, or actually I'm going to step into, because we're using a function. I want to actually step into that function if we get to it. When I step into one time, what happens is execution goes one line forward. We're at print header. I execute again, and now you notice that the point of execution jumped down to our function that we wrote. And if I keep executing, I actually jumped into the actual code that for that C++ libraries have, so I'm going to jump out of that using the step out. And so I'm going to step over so that we can actually see the results. And you see that the first line is now displayed on our console. I'm going to step over again. We see the next line. I'm going to step over again. The last line is displayed, and then step over again. And you see execution returns back to main and goes to the next line, which is this return 0. And now we've finished our program. So that was a demonstration of how a basic function works. We saw how now we can write code in a nice isolated function down here and split it out from main, and that kind of simplifies the way main looks. Rather than having all this functionality all in one function, we can write multiple small functions to do a bigger task. So let's do another function. This time we're going to do a function that we're going to call, it's going to be a function that returns a string, and we're going to call it getTextFromUser. And then down below we'll write a function to get user input. And I recommend actually copying and pasting your function prototype to start your function. That way you make sure everything's spelled exactly correctly. The function prototype and the function must be the same. So I'm going to create a variable for line of text, and then I'm going to cout, please enter a line of text. And we'll get line. And of course we get a squiggle because we need to have an include. So we're going to include the string library. And that gets rid of that red squiggle, which means that now that it recognizes what that is. And now we're going to introduce a new command, or it's called the return statement, and we're going to return line of text. So what the return statement does is it returns the value that is the type for that function. So since getTextFromUser, we declared that as a string, we need to return a string. Just as an example, if I return 0, for example, well, it might work. It turns that into a string. So it'll try to convert things over to what it needs. If this was declared as an integer, now we get an error because it can't convert that line of text to an integer. So the return has to match the return type, the type that the function is declared as. So in this case, get text from user is declared as a string, and so we return line of text, and line of text is in fact a string. Back up in our program, we want to get input from user. And we're going to need something, a place to put that text. So let's create a string called text from user, for example. So text from user is equal to, and we're going to call our function. And what happens is now it'll call this function, display this cout, get a line of text from the user, return that, and that'll be placed inside of this variable called text from user for us to use later on in main. Let's try that with Control F5. Please enter a line of text. This is a line of text, and we can see that it appears to have worked. And if I set a breakpoint here, I'll run in debug mode, and what we see is we're halted before the method call. I will step into that function. We see the execution goes into our function, and as we step over each line, it puts the input. Step over one more. So notice that at this point in time, line of text doesn't really have, if I click on locals, line of text doesn't have anything. But now I can see that line of text now takes on the value of what I typed in. This is a line of text. So what I typed in here is now assigned to the variable line of text. We can see that up here, text from user isn't in scope, so we can't see it. But I will step over. And we come back here now. Currently, line of text is equal to nothing. We can see here it's equal to nothing. When I execute this assignment operator, line of text now takes on the value that they got back from the method, and it says it now is line of text. So this is now in this text I typed here is in the console is now in this variable text from user. Now suppose we wanted to have a function that would convert all of that to uppercase. Well, we can say string convert text to upper, and we'll pass in a string. So here we have a function prototype for a function that returns a string, but also takes a parameter. And for our parameters, we declare type and then the identifier for that type. And you can put in as many parameters as you wanted. So if I wanted to put in a number, I could do that. If I wanted to put in a double, I could do that. And so You can put as many parameters as you want. In this case, we're just going to put one. Our function is going to take a string, change it to uppercase, and return it. And so down here, we're going to define our function. And so I'm going to need some place to put my results. So I'm going to put result text, create a variable called result text. And then I'm going to create a for loop. I'm going to go from int I equals 0 while I is less than, and I want the length of that text. So how do I know how long that text is? Because I'm going to go character by character through this text and make it uppercase. Well, I can figure that out, but if I place text is a string and string is a class, and knowing that, I can hit the dot operator on anything that's in a class, and you see that classes, they're in a lighter blue than the basic types like an integer. A string, since it's a class, I can hit that dot operator and I can get a whole list of different functions. So you can use all of these functions. You can compare, there's a copy, there's a begin, and if you go to MSDN website, or if you search under MSDN, and we'll search for MSDN string C++, and we search around, we can find that we can get some documentation on these different functions. And so the one we want to do is we want to find the length, and it turns out there's this length method, and if I click on that, returns the current number of elements in a string, and it gives me kind of a definition of that. And often we get examples that explain it. So we're going to be doing something along these lines. So if I put text.length, then that should give me the length of that string. It turns out there's also one called text.size. So if I put text.size, and it more or less does the same thing. So either one of those will work. And what I'm going to do is I'm going to take result text, and I need to initialize my result text to something. Remember, C++ doesn't initialize things, so I'm going to initialize it to the empty string, which is just 2 double quotes. And what we'll do is we'll set result text to, we'll add in, and I'm going to use this toUpper function, which is a character function. And again, going back to the MSDN website, I can look at C++ char toUpper and pick one of these. This looks like a good, possibly good. And it says converts the value of a Unicode character to its uppercase equivalent. Okay, that sounds like what I want to do. It gives an example here. And you can see here where it's taking these chars one by one and convert it to upper. So that tells me I can use that function to take each character and convert it to an uppercase. But now the next thing I need to know is where do I get the each character? Well, it turns out that text, I can treat it, and we'll talk about arrays more later, but I can treat it by an array. And if I put square braces and I put a number, an integer, it will return to me the char in that string at that position. So this will return when I is equal to 0, the char in the first position, i.e. at index 0. When it's 1, the next one at index 1, and so forth. So what we have here is a function, and I misspelled this, it has to be all lowercase, that will go through each character in this text string and it will convert whatever it is to the uppercase. And then what I want to do is return my result text. So you can see the advantages of writing functions. There's some complexity in doing this, but by writing as a small function, I don't have to do. I can put the code kind of separated from everything else, and it's a little bit more isolated, and it's a little easier just to think about this functionality, rather than having to think about it in the context of everything else that's going on with this program. So now we need to call our function and display it. So in our code, we are going to convert it to uppercase and display to user. And so I think I'm going to declare a string, call it uppercase text, and let it equal to convert text to upper. That's our function that we just created. And then pass into it text from user. And then we need to display that. So we'll say display uppercase version. And we'll display our new variable here, uppercase text. And what this will do is take the text we got from the user and convert it to uppercase. I'll try to run it with Control F5. So we get our input, and suddenly we see, yes, in fact, this works. It converted everything to an uppercase text. And how to do it? It used it with this function. And this function went through every character in the text using this for loop. Used the size method of the text of the string class to get the size of this. So it went from 0. You notice we used just a less than. Remember, our indexes are 0 based, and it's the same thing with a string. The first character in a string is index 0. So we go to 1 just less than the size in order to get the full string. And then we use the toUpper function, which will operate on a character. We found the character by saying text and then putting putting I in square braces that pointed to, so it pointed each character in turn, and then that returned the text, and then we got our output as uppercase text. Now suppose we wanted to do the same thing, but we wanted to display lowercase. Well, we would do the same kind of function, wouldn't we? We would and we can actually do this with a lot of cut and paste. We're going to change this to lower. So I'm going to take my function prototype for convert to upper and make one called convert to lower. And I'm going to take my convert to upper function and change its name to convert text to lower. It's still going to take a string text. It's still going to loop through each character, but rather than converting each char to upper, it turns out that there's also a function called toLower. And so same function really, except that we use a different effect on the char. And then in our main method, we'll create a different variable called lowercase text. We'll call our convert to lower method that we just created, lowercase version. And so now we've converted this functionality to one that displays lowercase. And put some uppercase and lowercase text in our line and see what happens. So here is converted all to uppercase, and this one we see everything was converted to lowercase. Okay, let's do something a little bit more difficult. Suppose we wanted to find a word inside of the user's text. So what we'll do is we're going to create a function, and it's going to and we're going to actually do this, I think, in main. So we're going to ask user to input some text to search for. And we're going to declare a string called text to find. And we're going to find and report the position of that text. So we're going to need the text location where it's located. It turns out that while this would have been a difficult thing to program, and we could have created a function and it could loop through to find that piece of text by doing multiple comparisons. Since this is a common thing to do, there's actually a function to do that. And we're going to take our text from user, and since text from user is a string, it was declared as a string, we're going to hit the dot operator, and we're going to look through these functions, and we're going to find that there's a find, there's find first not of, find first of. There's a lot of different find functions, and we're going to use this first one, this find function. Well, what does that do? Once again, I'm going to go to Microsoft's website and say C++ string find. See if I can find something on the find method. And it looks like there's something here. Basic string find searches a string in a forward direction for the first occurrence of a substring that matches a specific sequence of characters. That looks promising. I'll look at the example, And I see we here in this example we have a string 1, hello everyone, and it displays it, and it's looking for an E, and it's looking for the E that comes after third position. So in this particular approach, we pass an int and it finds one afterwards. Let's see if there's something a little more simple. Here we have a more simple approach where the string 3 is a sample string for this program, and then we have sample. This is find sample in string 3. So string 3 dot find, and then we pass it what we want to look for, and index 3 finds it. So that index will now then get the position of 3. The other thing we notice is that it has this interesting if then else. It's looking to make sure that it is not equal to string npos. Well, what is that? So I'm going to search for string npos, and if I search Google for it, what I'll find is string npos with these two colons is the maximum value for size t. It's a static member constant value with the greatest possible value for element. As a return value, it is usually used to indicate no matches. So I can see from this code here that they're looking for that, and if it does equal that, saying the substring perfect was not found. So I can now use this structure of the code to work for me. I will find the sample code inside of my string. I'll check to make sure that the index of that isn't equal to this string npos thing, and if it isn't, see we use a not equal operator here, then I'm going to do whatever I wanted to do to show where it was, and otherwise I'll put an error message. So now that I have that knowledge, I'm going to go back to my code. And so I'm going to see if I can find text to find. So here's the text that we want to find inside of the text that the user provided us. So text from user is the original string. Text to find is what the user wants to find inside that string. And then what we will do is we'll use that same if-then structure. So I'll say if text and I misspelled location up here. Fix that. Okay, if text location is not equal to string npos, and this double colon thing is interesting. String is actually a reference to our class, and it turns out that our class has a number if we put a dot we get functions, or if we get a dot on a actual string we'll get functions associated with it. But if we reference the class itself, to do the same sort of thing we put string and then we put 2 colons, and that gives us a list of functions and variables associated with the string class. And in our case we want npos. That means if it didn't come out to be the maximum value, then we're going to do one thing, else we're going to do another. And so if it turned out that it couldn't find it, we just want to put out cout text not found. That's a trivial case, so I'm going to put that one in first. And if it is found, then I'm going to cout found text to find in. So we found, and this is what we were looking for, and we found it in text to convert, or text from user. and then at text location and line. So we get the text location by using the find method of the string class. We pass to that method one parameter. So this is an example of where we're calling a method that was written by Microsoft, not by us. It works the same way as when we built our own functions, but instead of having to write it ourselves, we're using this pre-existing function that we got by putting the dot operator next to our string. And different classes will have different functions that are available to them. That makes sense because text from user is a string. It has things that would make sense from a string perspective. You wouldn't get functions which make sense from, say, a different class's perspective. This find method returns an integer, which is where the first instance where that string occurs. Now, if it doesn't find anything, it's going to put this maximum value called string : npos. This npos value will be placed in the text location. Since that varies, and since we can't all remember what the maximum value of a string is, we just use string npos, and we just check to make sure it's not equal to that. If it isn't equal to that, then that means text location has a valid pointer to or valid index of where that substring occurs, and then we can display a nicely formatted some nicely formatted text to the user explaining where this is. Otherwise, we just say text not found. So let's see if this works. I'm going to hit Control F5, click yes, and this is a line of text. We got our upper and lowercase, and then let's find something in your text. And so I'm going to put line, and it couldn't find it because I put the dot. Let me try again. This is a line of text. And I could put anything in there. If I just put text, or if I just put line, I'm hoping it's going to find where line is here. And it does. It finds it at position 10. Now if I were to add up the characters, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you'd say, well, wait, the index is 1 before. It's pointing to that space, not the up. But remember, this is 0 based. So we start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so the 10 is actually the index of the L. So in review, we created a number of functions. Some of them, the first one was void and had no parameters. The second one had a return type of string but didn't take a parameter. The third one, we took a parameter and returned a string. And then we duplicated that to create some different functionality, and then we used a function which came from the string class without having to write it ourselves. So this completes my demonstration of functions in C++. Thank you very much.